Hello, this is Andy from the Engineers Academy, and in this video series we're going to be looking at worked solutions to the Unit 1 Engineering Principles exam, which will be sat by students studying BTEC Level 3 Nationals in Engineering. Now, the document that we're going to be referring to today are the sample assessment materials that are or have previously been provided on the Edexcel website, and the document that we're going to be referring to in particular is Issue 1 of the sample assessment materials. Question 15 states the following. The diagram represents a transformer used by engineers as a power source for portable tools in order to reduce the hazards of working with power tools. The transformer is used to power a 100 volt power tool from a 220 volt alternating mains supply. The engineer has placed 748 turns of copper wire in the primary coil. So if we refer to our diagram, we have a transformer, and on the left hand side we have our primary coils, and on the right hand side we have our secondary coils. The question gives us some information. The transformer is used to power a 100 volt power tool from a 220 volt alternating mains supply. So the question's telling us that the voltage on our primary coils is 220. And it's telling us that the desired voltage, or the voltage on the secondary, needs to be 100 volts for our power tools. Now the question also specifies the number of turns of copper wire in the primary coil, NP, and it tells us that that's 748. Now if we refer to the question, it says calculate the number of turns required in the secondary coil. So that's going to be N subscript S. So we only have one equation that we need to apply for this question, and the equation that we need to apply is as follows. The number of turns on the primary coil over the number of turns on the secondary coil equals the voltage on the primary coil over the voltage on the secondary coil. Now the thing that we're trying to find, NS, is on the bottom of the equation there. So what we can do is we can recip each side of the equation. Now when we recip a fraction, the bottom becomes the top and the top becomes the bottom. And we're going to do that to each side. So what we'll end up with is NS over NP equals VS over VP. And hopefully now you can see that in order to get the variable we're trying to find on its own, NS, we need to multiply each side of the equation by NP. And we'll be left with NS, the thing we're trying to find, equals VS over VP times NP. So now it's simply a case of substituting in our numbers. We have VS, the secondary voltage, is 100. We have VP, the primary voltage, which is 220. And we have the number of turns on our primary coil, which is 748. Now multiplying that through gives us an answer of 340 turns. Now we can just check whether that appears accurate. If we're stepping down a voltage, then we're reducing the number of turns. And we see here that our voltage is roughly halving from 220 to 100. So we would expect the number of turns on the secondary coil to be roughly half the number of turns on the primary. And what we see here is we're going from 748 turns to 340 turns. So we can assume that our answer there is accurate.